This talk is an overview of NITARP, the NASA IPAC Teacher Archive Research Program. So as part of NITARP, teachers get an authentic research experience using real data and tools. We partner a small group of educators with a research astronomer. They write a proposal. It is peer-reviewed. They do the research. They write up the results. They take it to an American Astronomical Society meeting and present it in the science sessions. In this way, we model the entire research process in a little bit more than a calendar year. We've been operating since 2005. All our participants have to be US-based. We're actively recruiting for 2021 now, assuming that the pandemic doesn't adversely affect us. The application is due September 14th. All the research done by NITARP teams have to use data housed at IPAC. IPAC is at Caltech. It's where I work. Fortunately, there are petabytes of data available at IPAC. There's URSA, NASA's Infrared Science Archive, where NASA stores all sorts of long wavelength data. There's the NASA Exoplanet Archive and the NASA Extragalactic Database. Tons of data. All the research that NITARP teams do is authentic. That means that NITARP teams always present at least 2 posters, but only sometimes it produces journal articles just like any other poster at a AAS meeting. NITARP, combined with the program that preceded it slightly, since 2005, has produced 68 science posters, 72 education posters, 8 refereed astronomy journal articles, and 6 education journal articles. As part of NITARP, participants get 3 trips. They go to a January American Astronomical Society meeting to start. The day before that meeting, we have a day-long kickoff workshop for the NITARP teams. You go home, you work together, you write your proposal. You come back to visit Caltech JPL for 4 days in the summer. You go home, you keep working, and then you go back to the January AAS to present your results. We will pay for up to 2 students per educator on the second 2 trips. You can raise money for an additional 2 students, but we do ask that you limit it to a total of 4 students. You work remotely on the project a lot between the trips. After the main NITARP year, you're expected to conduct 12 hours of professional development or workshops, something locally, regionally, or nationally, basically sharing the wealth, sharing what you've learned. We are aimed primarily at high school teachers. We've also had middle school, community college, and informal educators benefit. We're not excluding teachers of younger or older kids, but our standard model doesn't work with that situation, and so we'd have to modify our approach. Because the T in NITARP is teachers, we really are working with the educators first. We're aimed primarily at high school classroom teachers. We've also had middle school, community college, and informal educators benefit. We work with educators specifically because of the leveraging potential and the long-term impact. So if I work with a kid and I change the way a kid thinks about science, that's great. I may change that kid's life, but my influence in that community leaves when the kid graduates. By working with teachers, if I change the way the teacher thinks about science, scientists, astronomy, astronomers, the amount of data that's publicly available right now, then I can influence through that educator the hundreds of kids that teacher reaches this year, next year, the year after, throughout their career. And it's hard to beat that leveraging. We only work with students through their teachers. We don't work with students without teachers in NITARP. These are just a few quotes that I have sprinkled through the talk. I won't read them all, but I wanted to highlight that at least one participant didn't realize that astronomy was not a done field, and that learning that it isn't is pretty exciting. And some participants describe the experience as life-changing. As far as we know, we're unique because of the combination of the things listed here. Our program is aimed at educators, not students. We select participants from a nationwide application process, so we're not geographically restricted within the country. Our program involves educators for at least 13 months. It's not just a few weeks, it's over months. Our participants do real research. There's no cookbooks here. Our participants present the results in the same sessions as professional astronomers, and they have to hold their own just like everybody else. They're not standing under a sign that says, please be nice to these people. They're high school teachers and students. They have to defend their work just like everybody else. Our participants are encouraged, but not required, to involve students in the entire process. Some teachers feel that their learning is best served by not involving students from the beginning, and that's fine. There is definitely a need for this kind of program given the widespread adoption of the NGSS. We have more than 5 people typically applying for each available spot. Some more quotes. I wanted to emphasize that people are telling us that we're doing pretty well. Each team has a mentor astronomer. Each team also has a mentor teacher who's been through the program before, and that person sort of acts as a deputy lead and translates between the astronomer and the teachers when needed. Each team typically has 3, sometimes 4 new educators. They usually are multi-state, so they usually cross time zones, but we try, for example, not to put the Maine folks in the same team as the Hawaii folks because they'd never be able to find a time to talk regularly. They meet for the first time at a AAS meeting. This was my team from 2008, and I love this picture because they all look like, what have they done? I promise you this team did well, and they took 3 posters to their second AAS. More reactions, in quotes, from the participants. They're learning that astronomers come from the engineering field and graphic artists. They're learning that astronomers are young and that they're friendly. After the AAS, the teams go home and work on their proposals remotely. They turn in their proposals, they get reviewed, and they have to revise the proposals in response. All the proposals are posted on our website. They do various things in the spring. Sometimes my teams do literature reviews. Sometimes they start working on data analysis. It just depends. Throughout all of this, they're having regular telecons, either every week or every 2 weeks. And you have to have really reliable email communications in order to make this work. In the summer, the teams come to visit us for 4 days. The date at which that happens is dependent on each team's schedule. The educators can bring anywhere between 0 and 4 students. We will pay for up to 2. These visits are very intense and usually represent the first time that any of these people have worked with data in this kind of detail. And it usually includes a half-day JPL tour. This is a 2012 team on their JPL tour. That summer visit is a really, really intense experience because we do work them hard. This year, as I record this, last week, my team met online, and so we had to do the whole thing over Zoom. More reactions from people. I do love the one teacher that had the realization that she was doing real astronomy and that she was really part of it now. So in the fall and winter, the teams go home and finish their projects. The AAS abstract deadline is usually early October. Each team presents 2 posters, one on education, one on science. They are submitted to the corresponding poster sessions, just like, so if they're doing science on star formation, they're in a star formation session. They're not cordoned off in a special part of the exhibit hall just, for educators, right? They're integrated with other poster presentations on the same topic, and so they have to defend their work just like everybody else. Because of the way the AAS works, each of the posters, the science and the outreach poster, is up for 1 day each. Most of the people we send annually are the people presenting results, which consist, of course, of the educators and the students. Recently, of the NITARP affiliated group of people at AAS, about 1/3 are new teachers, about 1/3 are finishing teachers, and about 1/3 are alumni teachers raising their own money. And then there's a whole bunch of students in there too. So this is a picture from the January 2020 AAS. And this is my team from 2010, or actually most of my team. There were several people we couldn't find at the time that we took this picture. But this is also a 2010 team, just to emphasize that not every teacher brings lots of students. This whole team decided they only had 1 student who was really working and keeping up, so they only brought 1 student to the AAS, and that's fine. More reactions from people. We seem to be doing something right. So a couple of important notes. Our oversubscription ratio is more than 5. That means that we have to turn away lots of good people who apply to participate in NITARP. Our target audience is educators who are ready for research but haven't yet done it. If you already have a PhD in astronomy or physics, you place out. If you already have a master's, you might place out. If you've already written a paper and gone to a AAS meeting, you probably place out. If you are in any of those categories, you should talk to me. I can put you in touch with some online tutorials or give you some other way of getting you up and running with data soon. I just want to emphasize, too, that this is not a replacement for master's thesis. We help you way, way more than you would be helped as a master's student, and you do way less math and programming, and you're working in a group. If you're interested in getting a master's online, you should try universities like Swinburne. This is also not a way of generating tons of science fair projects. Science fair projects are usually single author or at most 2 students, and by the nature of NITARP, you're working in a group. You are not going to become a science fair project generating machine through NITARP. You are going to learn tools and techniques that can be applied to projects, but you should not go into NITARP thinking that we're going to solve all of your science fair needs. I have done recently some education research on NITARP. We had 4 refereed education publications in 2018. I have another AAPT poster on this, but just for reference, those are the topics of the 4 papers, and the papers can be found on arXiv using those codes. So as a way to sum up, NITARP partners small groups of educators with a research astronomer for a year-long authentic research project in astronomy. We model the entire research process from proposal to poster. We've been operating since 2005, so we've definitely shaken the bugs out. We work with teachers primarily, and through them, students. We are actively recruiting for 2020 now. Please do help us advertise. The applications are due September 14th.